Using Kirchhoff's rule, find I1. So here an electrical network is given, and this network is having two components, that is two devices, two resistors and two cells having EMFs 40 volt and 20 volt. So how to solve this network? Of course, by using Kirchhoff's rule, this can be analyzed and solved. And looking at this network, we are able to find the currents, different currents, I2 flowing in this way, I3 through this path, and through this 10 ohm I1 is flowing. So Kirchhoff's first rule is about that is, it is applicable with respect to any particular junction. Suppose we are considering the junction F, then we are able to find that I3 is the total current entering to that junction. That is, only I3 is coming to that junction. And from F, we can find this I1 is moving away and I2 also moving away from that junction. And currents entering that junction is I3 alone, currents going away from that junction, currents leaving that junction, that is I1 and I2. And according to Kirchhoff's current rule, the total currents entering that junction, that should be equal to the sum of currents leaving that junction. That is I3, the currents entering, that is equal to the total currents leaving that junction. I3 is equal to I1 plus I2. So Kirchhoff's current rule is expressed. Now let us consider Kirchhoff's voltage rule. This Kirchhoff's voltage rule is applicable to any particular loop. Suppose we are considering a closed loop, A, B, C, F, like that. So A, B, C, F, A means this closed loop. A, B, C, F, A. Consider this closed loop. So Kirchhoff's voltage rule, according to this rule, the total potential in a closed loop, that should be equal to 0. Now when we are considering this closed loop, we can find three devices, two resistors and one cell. So we know when a current is passing through a device, that will create a potential. Potential will be developed. So the potential we know, according to Ohm's law, potential, that is V is equal to I into R. Potential is the product of current and resistance. So what about the potential developed across this resistor I into R, that is I1 into 10 I1. What about the potential developed across this 20 ohm resistor I into R, that is 20 I3. Now apart from these potentials, we know a 20 volt cell is also there. What about its potential? So we know this cell is the source, it supplies energy, whereas this devices consumes energy. So the potential developed across these devices, that is, we can say they creates actually the potential drops. So these are creating the potential drops, whereas the cell, that is a source, it supplies the energy. So the potential of the cell, that should be given positive sign, and since these devices creates a potential drop, their potential should be treated as negative. It should be given negative sign. That's what we are writing, minus 10 I1 minus 20 I3 plus 20, that is equal to 0. Then we got all the potentials. According to Kirchhoff's voltage rule, the sum of potentials in a closed loop, that is equal to 0. Then taking 20 to the other side, that is then negative sign is eliminated, then we are getting 10 I1 plus 20 I3 is equal to 20. So what is the meaning of this statement? So this side we have 20, that is the EMF of that cell. And what about this side? We know that is the sum of potentials. 10 I1 plus 20 I3, that is this algebraic sum of potentials in that loop. So we can make this statement in this way, that is, for a closed loop involving the cell, algebraic sum of products of current and resistances, that is equal to EMF of the cell. Means algebraic sum of potentials equal to the EMF of that cell. Of course, when we are taking the directions of current, for example, here two currents are there, I1 and I3. So here we are able to find that I1 is flowing in this direction and I3 also flowing in this direction, means the clockwise direction. So if we are preferring clockwise direction, then that current flowing in the clockwise direction or the currents flowing in the preferred direction, their potentials is taken as positive. And of course this cell also sending current in the positive in the clockwise direction. So we have all positive signs. Nothing. This is only the meaning for a loop taken in a definite order or a preferred direction of current. Algebraic sum of potentials will be equal to the total EMF of that loop, means that is equal to EMF of the cell included in that loop. Now considering the second loop, suppose we are considering this loop F, C, D, E, F, F, C, D, E, F. Suppose we prefer the clockwise direction, then all potentials created due to the currents flowing in the clockwise direction is given positive sign. Now with reference to the second loop, so this current I3, what is the direction of that? Earlier with respect to the first loop, I3 is flowing in the clockwise direction. Now with respect to the second loop, we know the I3 is flowing in this direction, means this is the direction of current I3 as viewed from this lower loop, means that flows in the anti-clockwise direction, opposite to the preferred direction. And what about I2 in this way, that also flowing in the anti-clockwise direction. So the potential created due to those currents should be given negative sign. So 20I3, that is minus 20I3, and here minus 10I2, minus 10I2, minus 10I2 equal to the total EMF. In this loop we can find two cells are there. So how to consider the effective EMF of a number of cells connected in a given loop? We know in this case we know if we have cells like this, we know this cell will be sending current in this direction and this will be sending in the clockwise direction. So they are opposing each other. Then if one cell is given, that is its EMF is taken as positive, then EMF of the other cell which is sending current in the opposite direction should be treated as negative. So in this case the total EMF will be 6 minus 3. Now if the cells are connected in this way, we know this cell is sending current in this direction clockwise, and the 6 volt cell, this also sending current in this direction, means negative terminal is connected to the positive of the other. So in this way they are aiding each other, and both are sending current in the same direction. So both the EMFs should be given the same sign, and if we are preferring clockwise direction, both EMF can be taken as positive. So in this case net EMF will be 6 plus 3, 9. Now coming back to our network, already we have preferred clockwise direction, but this cell, we know current from that cell as viewed from this loop, that is coming in the anti-clockwise direction opposite to the preferred direction. So this current also coming in the anti-clockwise direction. Then the net EMF will be minus 40 minus 20, that's what we are getting, minus 60. And I3 is I1 plus I2, like that we are substituting, and then eliminating the negative sign, and again we have the simplified statement here. Means after eliminating the negative sign from all sides, then we have 20I1 plus 20 I2 plus 10 I2, that is 30 I2. Then dividing throughout by 10, we got equation number 2. Now comparing 1 and 2, just multiply equation 1 by 3. So 3 into 3, 9I1 plus 6I2 is equal to 3 into 2, that is 6. New equation we are giving as equation 3, and equation 2 is taken and it is multiplied by 2. 2 into 2, 4I1, 2 into 3, 6I2, like that, and that is named as equation 4. And comparing 3 and 4, we can find these I2 terms are same. So if you are subtracting 4 from 3, I2 terms can be eliminated. So 5 minus 4, 5I1, I2 terms can be eliminated. 6 minus 12 is minus 6, and I1 can be calculated. I1. Now substituting the value of I1 in any of the above equations. Suppose we are substituting in equation number 1 itself, so we can find I2 also. I1 we got as minus 6 by 5, and here 2I2 will be equal to 3 minus 2I2 will be equal to 2 minus 3I1. 2I2 is equal to 2 minus 3I1, and substitute the value of I1, we will be able to calculate I2 also. And according to Kirchhoff's current rule, we got I3 is equal to I1 plus I2, and I3 can be I1 plus I2, that is equal to 8 by 5 ampere.